Good morning, everyone. Today we'll discuss another topic, which is on paradigm shift. Okay, so paradigm shift happens every day. It is a way on how science and technology progresses. So before that, let me present to you our intended learning outcome or our objective. So that is you should be able to identify paradigm shifts in history. Okay, so paradigm was first introduced by Thomas Kuhn. He is a philosopher, and he defined paradigm as a set of practices that define a scientific discipline at a certain point in time. So it contains all the distinct established patterns, theories, common methods, and standards that allow us to recognize an experimental result as belonging to a field or not. If we're going to compare this, or if we're going to relate paradigm in our daily living, it's uh it's like this one. Okay, so during morning, it what the main dishes we normally serve include, or the dishes that we normally eat include fried rice, fried egg or egg, um, hot dogs, chorizo, and among others. Okay, coupled with sikwate. Okay, when we go to restaurants, you normally, of course, you would see much like the same foods that you have at home. When you go to another restaurant, that's the same. It's because it's a set of practices. It is a set of practices which is happen to be common, um, common to a community, or maybe common globally. Okay, so that makes it a paradigm. It's a practices. Okay, so it's a comprehensive model of understanding that provides a field's members with viewpoints and rules on how to look at a field's problem and how to solve them. Okay, so paradigms gain their status because they are most successful in their competitors in solving a few problems that the group of practitioners has come to recognize as acute. Okay, so just like at present, we're looking for. I mean, every country is racing towards finding a vaccine for COVID-19. Okay, so they might be using different plants, different chemicals, or whatever potential drug they have, but they're following the same way as to testing its effectiveness in treating COVID-19. Okay, so the paradigm there is on the on the similarity of methods as to testing the potency of a particular drug to become a vaccine for COVID-19. Okay, so paradigm shift was then introduced by Thomas Kuhn. He's a trained physicist at Harvard University. He's a historian and philosopher of science through the support of Harvard's president, James Conant. So the renowned the structure of scientific revolutions helped to inaugurate a revolution, the 1960s historiographic revolution, providing a new image of science. For Kuhn, scientific revolution involved paradigm shifts that punctuated periods of stasis or normal science. So towards the end of his career, Kuhn underwent a paradigm shift of his own, from a historical philosophy of science to an evolutionary one. Okay, so in other words, there a shift in his career. Okay, so what was stasis or normal to him was that he was a he was a physicist, and eventually he became a philosopher. Okay, okay, so he defined a paradigm shift as a successive transition from one paradigm to another via revolution, which is the usual development pattern of how science matures. Okay, so again, this is what I said a while ago, that it is the very manner in which how science progresses. It's because of paradigm shift. It's because what it's sort of a knowledge that what we know today may no longer be the same tomorrow, and that doesn't mean that if there are changes that becomes a threat to the existing knowledge. Rather, it's a way on how that particular knowledge advances. Okay, so Paradigm shift is very common for scientists to discard certain models or pick up emerging theories. But once in a while, enough anomalies accumulate within a field that the entire paradigm itself is required to change to accommodate them. Okay, so if you are to if you are to relate this one to a particular drug that stands for a long time, known to be a drug for a particular disease, for example, an antibacterial drug for a certain for a certain species of bacteria. So over time, this particular drug has been used to treat that particular bacteria or to kill that particular bacteria. But over time, that bacteria becomes resistant. That become resistant. Okay, and so we need to find another drug. And so when uh, that drug becomes no longer effective in treating that bacteria, the new drug becomes the paradigm shift. Then, okay, and we need to accommodate that. Uh, it's because it's effective. That's one reason. Okay, so Kuhn believed that science has periods of patiently gathering data within a paradigm shift. So mixed in with occasional revolution as the paradigm matured. So a paradigm shift is not a threat to science, but rather the very manner in which it progresses. Okay, so this is how the Kuhn cycle looks like. We have the pre-science, the normal science, model drift, then eventually it proceeds to model crisis, revolution, then paradigm change or paradigm shift. Okay, so we begin with the pre-science. It's also called as the pre-paradigm stage. So in pre-science, there is not yet a model of understanding. So the understanding, so mature enough to solve the field's main problems. So the model may be close, it may be promising, and thus be attracting plenty of followers, but it is not yet real science that works because it doesn't quite work. It's a pre-science, so it's somewhat like um, there is a what do you call this one? Okay, we'll just have to stick with the vaccine for COVID-19. Okay, so if it's a pre-science, if for example you're able to discover quote unquote discover a particular vaccine for COVID-19, and it is not yet being applied throughout other communities, so maybe meaning to say it's still practiced in your community, and most likely it is not undergoing a lot of uh, clinical test that would really prove its effectiveness, and that would prove that it has no side effects. So that's pre-science. In other words, it is not yet again widely practiced. Okay, it becomes a normal science um, if pre-science. I mean, uh, if yes, it becomes a normal science if they begin in pre-science where they have a problem area of interest but aren't able to make much progress. So, in that case of of vaccine, so again, it is just used in your community. So maybe it's a medicinal plant. So there are no certain tests, or there are no high-end clinical tests which will prove its effectiveness. Okay, so when at last they have a guiding model of understanding, which Goen called the Freud's paradigm, they advance to normal science, where they remain most of the time, except when their paradigm undergoes a cycle of paradigm revolution. So, if it happens to be, I mean, if it is proven to be really, really effective based on clinical trials, and it is now being the vaccine is now used across mainstream societies, or it is now used globally. So it becomes a stasis or a normal science. Okay, so people become used to that. That when they, for example, they have COVID-19, when they are infected with COVID, so they eventually resort to this particular vaccine. It's because again, it's a normal that drug has become incorporated into the body of knowledge that is effective, and so it becomes normal science. Okay, So model drift is the second step of the Kuhn cycle. So the cycle starts in normal science, where a field has a model of understanding that works, and the model allows a field's member to solve problems of interest. So when the issues, problems, or phenomena appear as the model cannot handle, the model begins to drift away from the normal science. So as soon as more than a small amount of drift occurs, the field's paradigm is said to be in drift. So a solution is a model of understanding about how a system should respond when the solution is implemented. If the model is correct, the solution works. If not, it fails. Thinking in these terms allow us to learn from the body of theory of the Kuhn cycle, enrich the history of many past cycles of so many scientific fields. Okay, so in the case of the vaccine, it will drift. For example, um, if we found some anomalies, okay, so maybe it has a lot of side effects over its effectiveness in treating patients with COVID-19. Or its effectiveness may only be 25%. But then again, since we don't have other drugs that could be used as vaccine, so we have to rely on that 25% effectiveness. Okay, but then again, we see a lot of potential issues, problems arising within the drugs. One of it is it has a lot of side effects apart from being not so effective. Okay, so it undergoes a model crisis if in this step a field model of understanding has drifted so far. um, the field is drawn into crisis because they can no longer make rational decisions. Their foundation for solving their central problems cannot has been shattered by discovery of too many anomalies. Their central theory can no longer explain at this point in the cycle of the field's energies are best spent constructing a new model that works. Okay, so instead of improving that particular vaccine so that it will work, um, it undergoes crisis again if more and more anomalies are observed, and at this point, scientists are no longer interested with that particular drug. Rather, they resorted to finding another potential drugs which could replace that vaccine, which turns to be a stasis or a normal science. Okay, so model revolution happens um, if understand if in this step of a field's model of understanding is undergoing a revolutionary change, if the old model failed, which caused the model crisis step. So the model revolution step begins when one or more competing new models emerge from crisis. So this step is a revolution because the old model is usually so entrenched into the mental habits and even the lifestyle of those using it that a new way of thinking is incomprehensible or unacceptable, at least at first. So the model revolution step could also be called the search for a new model that works step. So the length of this step is best minimized if the consequences to failing to a new model in this time are catastrophic. At least this step is driven by an appropriate process. It is almost always rocky and necessarily slow and unpredictable. Okay, so model revolution is now leading to paradigm change. So it is the fifth and final step of the Kuhn cycle. So earlier steps have created a new model of understanding, the new paradigm. In the paradigm change step, the new paradigm is taught to newcomers to the field, as well as to those already in it. When the new paradigm becomes the generally accepted guide to one's work, the step is complete. So the field is now back to normal science step, and the Kuhn cycle is complete. So eventually, that particular vaccine is, should we say, um, what do we call this one? Phase out because it's not really effective and it poses a lot of side effects. And so, uh, during paradigm during revolution, we're able to look for another drugs or for another drug rather, which is better. So that particular drug becomes the new normal science or becomes the stasis. Okay, so I'll be sharing to you some intellectual revolutions that define the society and somehow proves Darwin's paradigm shift. So we have Copernican, Darwinian, and Freudian. Okay, so the Copernican revolution was the paradigm shift from from Ptolemy's model of um, the position of the Earth in the solar system. So, which described the cosmos as having the Earth stationary at the center of the universe, to the heliocentric model with the Sun at the center of the solar system. Okay, so Ptolemy's model was that the Earth is stationary, and and planets around us and even the sun revolve around the earth. On the other hand, it becomes a revolution because over the years Ptolemy's model um, is a normal science. People believe in it. It becomes a revolution again when Nicholas Copernicus revolutionized that thinking that the sun is the center of the solar system and the earth instead is revolving around it. Okay, so that particular revolution is consisted of two phases. The first being extremely mathematical in nature, and the second phase starting in 1610 with the publication of a pamphlet by Galileo. So, beginning with the publication of Nicholas Copernicus, the Revolutionibus Orbium Celestium, contribution to the revolution continued until finally ending with Isaac Newton's work over a century later. Okay, so actually, this theory by Copernicus um, was uh, was first um, less accepted by the people. It's because Ptolemy's model or the geocentric model was um, was influenced by religion, was influenced by their belief. We have we have high regard with the planet that um, that it becomes that we feel like um yes, that we are the center of not just the solar system but the universe, because it was influenced by religion. Okay, in other words, we have high regard to humans and to earth in particular. Okay, so what we are seeing right now, the motion of sun in yellow, earth in blue, and Mars in red. So at left, we have Copernicus heliocentric model. So again, we are just revolving around it. Then at right, we have a traditional geocentric model, or geocentric motion, including the retrograde motion of Mars. So for simplicity, Mars' period of revolution is depicted as 2 years instead of 1.88, and orbits are depicted as perfectly circular or epitrochoid. Okay, so this is now as if we're going to compare here, the sun is the center of the solar system, so this is now heliocentric model of Copernicus. This one is the Ptolemy's model of the position of Earth, Sun, and some planets. So again, we're at the center of the solar system, and if not of the universe. Okay, so we also have Darwinian revolution. So Darwinian's revolutionary theory was the new species arise naturally by a process of evolution rather than having been created, forever immutable by God. So according to the well-established creationist theory of Darwin's day, the exquisite adaptations of many species, such as the hinges of the bivalve shell and the wings and plumes on seeds dispersed by air, were compelling since the evidence that a designer had created each species for its intended place in the economy of nature. So this in a nutshell how Darwin's revolution or Darwin's theory and survival of the fittest looks like if put into a diagram. Okay, and we are going to compare that one with Lamarck. Okay, because Lamarck's theory is use and disuse, and they use same um, organism, which is giraffe, to explain their model. So for Lamarck, he believed that there are only one type of giraffe. Okay, so this giraffe developed its characteristic over time. Okay, so this is the scenario. Um, there are giraffes, so they have two access for food. One is the grass, and the other one is the twigs of the trees or the leaves of the tree. Okay, so over time, these giraffes have to eat through the grasses, and when the grasses um, or when the supply of food in on the ground was depleted, so they have to resort to another source of food, and the second source of food that they have are these trees. Okay, so why it is called theory of use and disuse? It's because their neck has been constantly used to access food, um, which is on the tree. Okay, so that explains that their legs have to extend in such a way that they will be able to again to reach or to access that particular food. Okay, but for the case of Darwin, his theory is different. Okay, so um, for him, there are also two types. There are two types of giraffe. One have short neck, and the other one have long neck. Okay, so still, there are two access for food. One is on the tree, and one is on the ground. One is a tree, and the other one is on the ground. Okay, so um, what these giraffes do over time is that, of course, they have to compete for food. It may be through the grasses or through the trees. Okay, over time, again, the grasses will be, how do we call this one? The grasses um, will be, the food or the resources for, which is on the ground will be depleted. And so these, they have to resort into the leaves. Okay, and so these short-necked giraffe are not fitted into the environment because basically they cannot reach the leaves or the twigs from the trees, so they will die over time. Okay, and what will be left are these long-necked giraffe because they're adapted into the environment. Okay, so we also have the Freudian Revolution. So Freud is a psychoanalyst. So psychoanalysis is a study that explains human behavior. In his theory, Sigmund Freud explained that there are many conscious and unconscious factors that can influence behavior and emotions. He also argued that personality is a product of three conflicting elements: the id, ego, and superego. So the three agents are theoretical constructs that describe the activities and interaction of mental life. So in the ego psychology model of the psyche, the id is a set of uncoordinated instinctual desires. The superego plays the critical and moralizing role, and the ego is the organized, realistic agent that mediates between the instinctual desires of the id and the critical superego. Okay, so for your task, you're going to discuss some scientific revolutions of the following indigenous cultures, which turned into cradles of early science. So, development of science in Mesoamerica, in Asia, in the Middle East, and in Africa. Okay, so this is my source. That ends our presentation. Goodbye.